Hi, welcome everyone. So this is my first video in which I will be explaining you what exactly ETL pipelines are. With that, I will also, try to explain some GCP services that will be used in creating and developing ETL pipelines. So I will not spend much time in overview and all those things. I'm expecting people who is watching this video has basic information or basic knowledge of cloud services, most preferably in GCP. So let's move and see and dive what it's all about. So first of all, we will see like what ETL pipelines are, what are the components of ETL pipelines, benefits, and then a small quick introduction of GCP and its services that are used to design an ETL pipeline. Then we will see a small scale version of ETL pipeline, a basic ETL pipeline architecture, so that you can understand like how things work as a whole. Then we will also try to give you a demo. In that demo, I will try to explain how things are created, how things are done. So let's move ahead. So first of all, when we talk about ETL pipelines, so ETL pipelines are just a combination of some services, technologies, tech stacks that allow our data that is residing in a database, maybe it's SQL, maybe MongoDB, or any kind of relational database, or if not, then MongoDB, uh, non-relational databases, NoSQLs. It can be a file, so data can be in any form. So it's about extracting that data, pulling that data at a place, cleaning it, transforming it, enriching it, then using that cleaned and enriched data to get your data analysis done. So to do a data analysis and do all those stuffs that gives you a big picture like what data is, you will be loading this data in a BigQuery. I'm taking example of BigQuery. It can be any data warehouse technology around you or you of your knowledge. But for now, for this example, it's BigQuery because we are focusing primarily on GCP services. Moreover, so this is how and how what we will be doing in ETL pipelines, and this is what ETL pipeline is all about. So let's move ahead. So as I already explained, like the basic components of ETL pipelines: extract, transform, and load. Okay, here is a catch. When we talk about ETL pipelines, there is one more thing people must know is ELT, extract, load, transform. That is something different, but kind of a same thing. But we will not focus on that for now because we have to keep this a video short. So extract, transform, and load. So let's see. But before understanding what how we create ETL pipelines and how we do the all setup and codings, we must know the benefits. Why it's required? Why ETL pipelines are required? So as I was talking previously, it's a way to collect the data, enrich the data, uh, keep it at a place where you can analyze, you can put all the sort of filters, any kind of dashboard you can create with that. You can use it in creating your ML models, do predictions, anything you can do with that data. So data must be of a high quality data. So that's what ETL pipeline is doing here. So as you see, it keeps your data centralized. It's improved the quality of data. So and when we talk about pipelines, so those pipelines are kind of automated pipelines. You don't have to worry about how things are moving. You don't have to check it again and again and try to create the and run the pipelines. It's all automated. You don't have to just have to you just have to monitor the logs and all the transformation that are done. If there is any error or any kind of downtime scalability issue, you just have to watch that. But when I talk about the scalability, the ETL pipelines are majorly designed to handle the scalability of large data sets. It doesn't sit as a duck if there's a large data is thrown at the pipeline. So it is efficient. And when we talk about GCP, it's really efficient. Next, it really enables the business person or the stakeholders that run the business, that create strategies, that do all those things. So it's a very core tool for those people to understand their business. There could be historical data of around 20 years, 25 years, that can give them an insight like how things has come to this point, now what they have to do to go ahead from this point. So this is how ETL pipelines helps. So it's a big thing. So now we will see how an ETL pipeline can be designed and developed in GCP. So before starting to designing and even developing the ETL pipelines in GCP, I would like to tell this thing like ETL pipelines can be designed in any cloud platform, or it can be a multi-cloud architecture as well. We have this ability to scale the ETL pipelines in a such a way it can be multi-cloud architecture as well. So for now we will take example of GCP. So as we know, GCP is a is a platform provided by Google to design and develop your cloud solutions. So right now we will see some of the available solutions in GCP that can be used to design an ETL pipeline. Okay, so these are some very commonly used services of GCP that are uh, listed here: cloud storage, BigQuery, Cloud Dataflow, Cloud PubSub, Dataproc, no, Composer. Composer is basically a managed service of Airflow. So these are some services, and the combination of these services leads to a very efficient ETL pipeline. Okay, so we will focus on some basic services, or I would say those services only, which will be used in our this demo of creating an ETL pipeline. So first of all, every cloud network has this concept of VPC. In GCP, it's a isolated network, I would say, a VPC network where you can create your infrastructure. This provides you ability to segregate your workloads, environments, databases, compute engines, any other infrastructure services that you have created. So it gives you isolation, it gives you ability to make any network public, private. So it gives you a whole list of combinations that you can create using VPC networks. So VPC network generally consists of subnets. You can create subnets in different regions, and obviously those regions also have zones as well. In GCP we have zones, but as in AWS we have one more concept that are known as availability zones, but for GCP we only have zones for now. So you see this diagram that we are seeing, the something in the blue background is GCP network, in which we have created regions. One region is US West 1, another is US East 1, and then we have two different subnets in that. This gives you an ability to create isolated environment. So let's say some VM running in subnet 1 in zone US West 1A is kind of isolated from the something running in region US East 1 in subnet this subnet 192.168.1024. So these are isolated, so this feature is something helps you to maintain privacy, security while designing an architecture. So for now, for our demo, we will be using default VPC, that is a kind of a global in behavior. So don't worry about that. Next we have GCS, is a cloud storage service. Obviously this is something to store our files, whatever files we collect, whatever data we collect. It is something uh, a place where you hold your data that will be, later picked by the pipelines. So GCS is very useful while creating a pipelines. So this is what GCS is. Then Cloud Composer. So Cloud Composer, as I already mentioned, it's a managed service of Airflow. Airflow, that is a open source thing, and it is mainly used to create scheduled uh, workflows, very complex iterations of workflow, and it's like I would say backbone if you are using an Apache Airflow for your ETL pipeline. So it gives you a variety of features. First of all, as I already mentioned, it's a managed service. It is kind of integrated in GCP as a cloud composer. It has a a very robust, trustworthy security and compliance feature. Obviously, it's scalable and easily monitored. It provides something called a graph where you can see and monitor your steps, how it's going, how it's been, it's been carried on, all your flows. So this is what Cloud Composer is. You will see in demo how it works. Then we have this Cloud Run function. It's a serverless compute solution provided by Google Cloud. So you don't have to worry about any of your architecture behind. So you don't have to worry about any servers, any VMs, anything. You don't have to worry about, even IPs, anything. You just have to put your code in a function, and this will be triggered or maybe run by any other GCP services. For our use case, it will be triggered by event track using event track with the events triggered via GCP bucket. Whenever a file is uploaded to GCP bucket, this function gets triggered automatically, and this function will basically give a way to next steps in the ETL pipelines. So this is a Cloud Run function, and yeah, this was previously known as Cloud Functions, but now it has been a part of Cloud Run function. So Cloud Run is another feature of GCP. Now Cloud Function is a part of Cloud Run. Okay, then this is the Dataflow. Dataflow in itself is a very big concept. We have something, if you guys know about Apache Beam. So it's Apache Beam itself is a kind of data flow. I would not say it's a data flow, but Apache Beam is used to create data flows, and Apache Beam supports different languages like Python, Java, and other languages, set of languages that is used to create your data flow steps and how data moves from one step to other step. But in our demo, we will be using some predefined templates to make things simple. Because if I have to create something in Apache Beam, then I have to create a different altogether a tutorial about Apache Beam. So I'm skipping that. I'm just following default templates for it. So let's see how a data flow is used in our data pipeline. So it allows you data movement. It also helps you in the extraction, transformation, and load. It allows you to push the data in the BigQuery that is further been used to creating the dashboards for the business stakeholders. We can also apply MLs on that. It is used to process the sensor data. So there are a lot of features available, and there are multiple use cases where this data flow is very useful. So this is something very good feature of GCP service that we can use. Then obviously BigQuery is something, the destination where we have to, last destination I would say, where we have to put our every process data, and it's something termed as a load step. So everything that we are doing till now is all just to reach to this step. putting everything in BigQuery. Why BigQuery? So BigQuery is basically a data warehouse, given by Google, and you can store multiple rows, terabytes of data, petabytes of data in BigQuery that is later used by data engineers, or I would say any other person who tries to analyze it or maybe use it to create machine learning models. So this is how BigQuery is useful. So there are some features I have listed down. Some features that are very you know spatial. That's why it's Google BigQuery is preferred. So first of all, the thing is like it supports SQL queries. So anyone who has even a basic knowledge of MySQL, SQL queries can easily run the big queries. Then you can create machine learning models. BigQuery ML, you say, is named as BigQuery ML using the SQL queries itself. So you don't have to create models and all that things. It's all query, and queries itself contains machine learning features. So it's very easy to implement machine learning models on the BigQuery using simple SQL queries. So that's a different feature in it. Then now if you talk about the architecture of BigQuery, so it's really impressive to see that the data where the data is stored at a different place and the compute is happening in a different place. So it's a kind of separate architecture that can scale at a different levels. So it's not coupled, it's a decoupled architecture, and that's why it's been priced in a different way as well. So data in when data is stored, it's priced in a different way, but when it's been queried or used somehow, it's priced in a different way. So pricing is also very flexible due to this decoupled architecture. Further, the storage of the BigQuery is also known as a columnar structure. So data is not stored as a row pattern mainly. It is stored in a column way. So it's makes very easy to query the data, and I will show this how this makes difference while we query. So we will see that in demo, like how columnar thing works. Then the one more important feature of it, like let's say you have a ETL pipeline that is extracting data from somewhere else and putting it in a BigQuery. With this thing, it also provides the ability to analyze some data that has not been extracted, but it is in some other place, maybe in some other cloud, or maybe in some other database. You can directly query that database using BigQuery only. So you don't have to copy the all data to the BigQuery and then you have to do the analysis. So no, you can easily use the external table features to query the other databases as well. There are some set of database that is supported here. That's a restriction, but yeah, it helps you to it gives you ability to analyze other databases as well. Then this is a query caching feature that helps people to minimize their pricing things, budget things. It basically queries every results that has been fetched previously. So whenever a query has been ran, obviously one time, then obviously it will be not trying to use the compute resource to again search for same thing. It will query that result and it will be presented in front of you. So this query caching thing it really helps to minimize the costs. Then this is a Looker Studio. It's all about reporting, so we will see this Looker Studio as well. It's a very easy to use drag and drop things, so we can just connect that BigQuery table from where data is to be pulled in. Then we can just, it's like paintbrush, I would say. You just have to drag and drop and you can create or visualize the data in whatever possible ways you can. So that's a very easy thing.
This is all about the theory part of ETL pipelines. In next video, we will see the creation of ETL pipelines, how it's been created, how it's been executed. So let's wait for next video, and thanks for watching this video.